I want to continue to push the boundaries of implant dentistry until I can help 100% of patients with 100% predictability and 100% success rate. Hi again, everybody. Welcome back to episode number 2 of the Dental Implant podcast with me, Pap Kara. I was reflecting back on the one that I did a few days ago. I think I rambled a little bit, but that's fine. That's not a problem at all. I'll be learning as I'm going along. I'm excited to be doing this again. I'm always open to feedback. So if you've got any topics that you'd like to discuss, just fire over a message to me and I'll see how I can help you out. And we've got some great things to discuss still. So just before we move on to today's episode, just to let you know that I have confirmed with Riazia that we are going to be doing the podcast on occlusion. We're just trying to sort out a date to record that, and hopefully we'll be able to record that in approximately the next 2 or 3 weeks or so. That'll be edited, we'll get it up live, and that'll be a really good one, I think, a really good one. We've already hashed out a few things that we want to discuss. I think it's going to be a very, very interesting discussion. So today's episode, what should we talk about? Well, I had an idea. Why not talk about what my master's dissertation was on, which is hydrocarbon contamination of implant surfaces and biological aging, which sounds really quite weird and out there, but for those of you who know me, I like the weirder and more out there stuff. I don't like doing the stuff that everybody else is doing. So this is more aimed at people kind of like who are already placing implants. They're quite comfortable with it, but you'll still get quite a lot from it, even if you're a beginner. It might just go over your head a little bit, but you can always come back and watch this again at a later date, and you can always shoot me over some questions. This will also go really well for those who are placing implants at an extremely high level. If you're doing full arches, if you're doing zygomatics, if you're doing oncology, this is going to be some really interesting data for you. So let's get started, I think. So how did I come across this? I can't even remember. I was doing some research for my master's, and I came across a paper dating back to about 2009. And in this paper, they were talking about how once an implant has been manufactured and processed, it's sent out for sterilization, it's packaged and it comes back. If you look at the shelf life of these implants, quite often these shelf lives are several years. So they're sat on the shelf for a long, long time. And this paper called Biological Aging of Implant Surfaces demonstrated that what happens is even inside the packaging, and there is no implant system, not a single one, that is immune to this biological aging phenomenon, that what happens is the surface of the implant starts to interact with the air just within the storage vial. Okay. And what it does is it significantly reduces the bioreactivity of the implant surface. Let me say that again. It significantly reduces the bioreactivity of the implant surface. What does this mean? It means that the implant struggles more to integrate to bone. Okay, and we're going to come on to how this impacts in a few minutes. Yeah, interesting. Yeah, and you may be sat there thinking, well, it's as long as I use the implant quickly, what's the harm in that? Well, the reduction is first noticed within 24 hours. So in less than 24 hours, there is a measurable drop in bioreactivity of the implant surface. And this peaks after 4 weeks. So 4 weeks of storage means that your bioreactivity is cut in half. And these are the implants that we're putting into patients' mouths. Interesting, huh? Well, I find it interesting, but then I'm a geek. You guys know this already. But let's take half a step back and think about that for a second. So we are getting good, predictable results using these implants, which have just been stored for quite often more than 4 weeks. So you may be sat there thinking, Pav, why should I take any notice if our success rate's already very high? Well, my personal philosophy is I want to continue to learn. I want to continue to push the boundaries of implant dentistry until I can help 100% of patients with 100% predictability and 100% success rate. I know that's very unlikely to happen, but that's my aspiration. Wouldn't it be great if we could actually do that? Okay. So we're not talking about the vast majority of implants which are fine. We're talking about those handful of failures which cause a problem in the practice. And we are also talking about medically compromised patients who we may be able to help better if we were to remove this hydrocarbon contamination from the surface of the implant just immediately before it goes into the mouth. Okay. So a summary of that is implants manufactured, it's cleaned, it's sterilized, it's packaged. Within 24 hours, there's a marked drop in bioreactivity of the implant surface, and that peaks after 4 weeks. And after 4 weeks, your bioreactivity is reduced by 50%. Okay. So what actually happens? So there are a couple of things which happens. Firstly, you get hydrocarbon contamination of the implant surface itself. And what that does is it reduces the amount of titanium oxide which is actually available to interact with the actual bone itself. And the other thing that it does is it reduces the hydrophilicity of the implant surface itself. Okay. Now, before anybody starts talking about SL active and things along those lines, I will come back to that in a minute. Okay. Because yes, it does work, not as well as what I'm going to, and I've got some concerns about that. And I've asked some questions and nobody's given me a satisfactory answer to those yet. Okay. So we have established that hydrocarbons contaminate the implant surface. And it's also been found that it happens on zirconia implants as well. So if you think about the whole process of implant manufacture is to make these implant surfaces, which are ready to react with blood proteins and induce a healing cascade, which will lead to predictable osseointegration, that's true whether we're talking about titanium implants, and it's also true whether we're talking about zirconia implants. Okay, so what happens when we start to remove this hydrocarbon contamination off the implant surface? There are currently two ways of doing it. So there are ultraviolet C chambers, which are commercially available from a couple of different suppliers. And there is an implant, which is the Toman implant, which uses a very weak alkali solution. They use a 0.0, I don't like the term naught, let's do that correctly, 0.05 molar NaOH solution. So it's a very weak alkali that they dip the implant into. They agitate it and leave it for 30 seconds before it goes into the mouth. And that will also reduce or eliminate the hydrocarbon contamination off the surface. What that does is it does two things, is as well as opening up the surface area of the implant for integration, it improves the electrostatic charge on the implant surface itself. So what does that mean? You actually get faster and better blood protein chemo attraction to the surface of the implant. Okay. And what that means is the patients heal better, they heal faster, significantly faster, not even just a little bit, not even a little bit. So Ogawa and his team back in 2012 demonstrated that if you use a UVC chamber on treated surface implants, which we know the average amount of bone to implant contact ratio is around 56%, that will jump up to 98%. Within 4 weeks, you get a 98% bone to implant contact in 4 weeks once you remove the hydrocarbons off the surface of these implants. Okay. It doesn't just work on treated surface implants as well. It actually works on machine surface implants. So the amount of bone to implant contact ratio that you receive on machined surface implants jumps up to 79%, which is huge. It is still above the 56% that we gun for when we expect integration of implants. And this is one of the things that really got me thinking about this. We can get predictable integration of machined implants. What's one of the biggest issues that we have out there at the moment? Peri-implantitis. It's this infection around the implants. And that infection skyrocketed once we started treating the surface of the implants. The issue that we used to have with machine surface implants is their unpredictability in their ability to integrate. Once they did integrate, they tended not to become infected so much. So hang on, we now have found a way to improve the integration of machine surface implants to go above what we currently accept for treated surface implants. Can't this mean that we can predictably go back to machine surface implants? And that is one of the reasons why I really wanted to research this in more data. The papers also found that as well as increasing the bone to implant contact ratio, everything in relation to that healing cascade is upregulated, okay? So as well as having an increased bone to implant contact ratio, they were also finding that the bone in contact with the implant was significantly more mature. There were larger osteoblasts and osteocytes around the implant compared to the test models. So not only are we getting increased integration, we're getting healthier bone around it. We're getting stronger cells around it. Everything's upregulated. And this makes perfect sense because once you remove these hydrocarbons off the surface of the implants, then the electrostatic charge is improved. And one thing you will notice with these implants is once you've treated them and they go into blood, the blood zooms up the surface of these implants. You restore the hydrophilic nature of an implant. And that is incredibly powerful. Now, for a second, let's talk about preservation mediums. Okay, you get a lot of implants nowadays which are stored within, it's effectively a salt solution to preserve the hydrophilic nature of the surface. Now, we know that grade 5 titanium and its alloys will corrode more than grade 4 titanium. We also know that those corrosion products are linked to peri-implantitis, okay? Now, what I will say is these preservation mediums, do they work? Absolutely they do. Yes, they do. They maintain the hydrophilic nature of the implant surface, and you get better integration, okay? Now, there was a paper that I critically appraised where we took preservation mediums versus using ultraviolet C chambers, and the preservation mediums, whilst they did work, were not as good as removing the hydrocarbons just before implant placement. The big question I have, and I've not been able to find an answer to this, if anybody does know, please send me the data because I want to look at it. I really genuinely want to look at it, okay? These implants, which are contained within a preservation medium, does that preservation medium increase corrosion of the implant surface? It's a sensible question to ask, right? If we know that corrosion products can lead to peri-implantitis problems and we're sticking it in a salt solution, should we not then be asking, is that salt solution actually increasing the risk of corrosion? I don't know. I don't have the answers to this. Maybe it does, maybe it doesn't. For me personally, I'm sticking with my UVC chamber at the moment because it's working incredibly well for me. So I am using an implant which has a machined neck towards the surface. And I have to say I'm getting very stable bone levels and very predictable integration. Now, why did I make that statement when I've just said that we can get predictable integration? Because the data that I've read with regards to removing hydrocarbon contamination of off the surface of the implant, I haven't been able to find any long-term data on it. So I don't know whether that maintains its stability over 5, 10, 15, 20 years. What I can tell you is in the short term, yes, absolutely it does. And then if we think about it, the vast majority of our issues happen within the short term. Now, going back to what we were saying a few moments ago about medically compromised patients, if you've got patients who are overweight, they've got cholesterol issues, they might be osteoporotic, they might have diabetes, although it's relatively well controlled, they may be on antidepressants, they may be on omeprazole, things along those lines. Should we not be doing everything that we possibly can to increase our chances of success with those patients? So it's not just the healthy patients, it's those who are medically compromised. And it's such a simple system. My cycle takes me 12 minutes. So quite often is, if I know the diameter and length of the implant that I'm doing, I put the implant into the UVC chamber. It's got a 12-minute cycle on this particular one, and it's underway as I start my procedure. And quite often, by the time I'm finishing my osteotomy, there's just a few minutes left to go to take that implant out. So it doesn't actually add significant amount of time to my procedure. Okay. Minamikawa and colleagues in 2014 demonstrated I'm reading off my paper, demonstrated a 100 to 120% increase in the force required in a biomechanical push-in test to induce failure, okay? So they took, and this was an animal paper, well-designed animal paper. They took these implants, they had the test samples, and they had the photofunctionalized treated samples, okay? The amount of force it required for a push-in test on the ones which had the hydrocarbon removed to induce failure was twice as much as what it was for the test sample. Twice as much. We're not talking a small increase of 5%, 10%, 15%. We're talking about doubling the biomechanical lock on these implants. Now, one thing that I did look for, and again, I couldn't find any data on this. This would be an interesting study to do, is let's say your standard implant, untreated, goes in place, 56% bone to implant contact ratio. Well, what's the other 44%? It's a mixture of all sorts of stuff, including soft tissue. And I had a question as to whether that soft tissue could potentially be, or whether whatever's in that other 44% could potentially be a source of infection, which maybe cause peri-implantitis down the line. So it'd be interesting to see whether this increase in bone to implant contact ratio, A, maintains over a long time frame, but B, whether it actually reduces the risk of peri-implantitis long term as well. I don't know. I don't have these answers. These are just, there's an old saying, for every one question that you have answered, you've got 3 more that creep out of the woodwork. And this is exactly what's happening. SEM investigations demonstrated a considerably elevated degree of mineralization of bone in contact with the treated implant surfaces. Okay, the combination of increased bone to implant contact ratio, greater degree of mineralization of bone, and in shorter time frame may be considered on a simpler level as better, stronger, and faster integration. That's interesting. That's interesting. These papers are very, very interesting to read. Okay, and let's think of it from our point of view. It's who doesn't want better, faster, simpler osseointegration? Who doesn't want to have fewer failures? And as I said, this is one of the reasons why I looked into this, because I just found it very, very interesting. Okay. Also, a study done by Yamada and colleagues, and they showed a reduction in biofilm formation on implant surfaces after they've been treated and had the hydrocarbons removed. That's interesting. Now you think about the full arch cases that we're doing. We think about, I don't do oncology, but it's the oncology cases. Quite often these are very extreme cases. Could we not be treating these to reduce risk of issues around these? Again, when we're talking about zygomatic implants, these are extremely resorbed maxillae. They're quite often these patients, they're at the end of the line, and a lot of the implants out there, they have a machined neck because there's so much of the implant that's not contained within the bone itself. Well, if we've got something that starts to become resistant to biofilm formation, and again, I don't know whether this is prolonged or even in the short term, but even if it's a short term, if you've got this resistance to biofilm formation and increase in bone to implant contact ratio, you're just starting to reduce your risk factors significantly. So again, that's something else that I found very, very, very interesting as well. So the main hypothesis with regards to how hydrocarbons interfere, have touched on this previously, is this bioreactivity of the implant surface actually attracts the hydrocarbons. It binds to the surface, reduces the amount of surface area that's actually available to the body to interact, and it alters the electrostatic charge. So the blood proteins, they don't get that faster hematostatic attraction. They haven't done other studies where they are suggesting it may be that when we remove the hydrocarbons and put the implants in place, that it will actually improve bone grafting results as well. Now, if you think about that, if you've got a bigger pull from the implant surface drawing blood towards the implant surface, how's that not going to help bone grafting? There's a lot of data out there which we're finding very, very interesting. How much hydrocarbon contamination do you get on the surface? Let's go back to Mora and colleagues. I mean, all the way back in 2003, they demonstrated hydrocarbon contamination happens to all implants. Anywhere between 20 and 80% of the implant surface will become contaminated with hydrocarbons. That is an insane amount. That is just absolutely huge. Now, again, if it was 1 or 2%, you could argue, 1 or 2%, how much difference is that? Right? But if you're talking, let's average it out. Let's even say 50, 60%. If you've got 50% contamination of the implant surface and you're putting that into a patient's mouth, why shouldn't we be removing these hydrocarbons? Why shouldn't we? And again, we are talking about Lee and colleagues in 2012. They demonstrated that the ability for fibronectin to attach to the implant surface reduces by 40% in 24 hours. That's the data I was looking for. So when I say that it's measurable after 24 hours, it's not a tiny measurement. That it's reduced by 40%, okay? And it peaks to about 60% reduction in bioreactivity after 4 weeks in storage. It's just a huge amount. The same colleagues, Lee et al., they showed a 50% drop in bone to implant contact ratio, which we've touched on that already. Is there any difference between using a weak alkali solution and using a UVC chamber? No, there isn't. No, there just isn't. They both work effectively. They both have the exact same identical outcomes. All you're doing is you're removing the hydrocarbons from the implant surface, and then the implant does the rest. So that's why there's no difference between the two. You're not altering the implant surface. You're not changing anything. It's just like a factory reset that we're doing. So on untreated samples, the water contact angle, which tells you how hydrophobic or hydrophilic something is, on an untreated sample, it was 85 degrees contact angle. Once you've removed that hydrocarbon contamination, you get a 0 degree contact angle. It's super hydrophilic. And this is what I'm saying is once you remove the hydrocarbons off the surface of the implant, you dip it in, just test it, dip it in water. You'll see the water just zoom up the surface of the implants. Now, cell attachment is they demonstrated 80 to 100% more cells compared to untreated samples with an 8-fold acceleration in cell attachment. That's huge. So you get twice as many cells and 8 times faster. Okay. The cells themselves were significantly larger. They tested biomarkers for osteoblast function. Okay. So osteoblast function will basically tell you how much integration is actually happening. And treated samples were 80% higher. 80, not 18, 80% higher. Okay. And again, the push-in test is, it was twice as strong in resistance to failure. Okay. And that was and they got similar results on machine surface implants. This paper, I want to find you the data from this, because this was really interesting as well, because they used human blood to test. And what they found is, again, everything was upregulated. The amount of coverage of blood actually in contact with the implant surface. On an untreated sample, the amount of blood in contact was only 30%. On a treated surface, it was 90%. They're just complete worlds apart. They're just absolute worlds apart, okay? The description of the blood clot under SEM investigation, the blood clot was just significantly more fibrous. Everything was upregulated. The amount of surface that was covered by platelets. So on an untreated sample, 30%. On a treated sample, 66%. Platelets in contact with the implant surface. Significantly denser fiber network around the implant as well. This is the interesting one as well. The thickness of the blood clot. So on an untreated sample, the blood clot thickness was 20 micrometers. On a treated sample, it was 35 micrometers. That's huge, okay? So far what we've discussed is all implants, whether titanium or zirconia, are susceptible to hydrocarbon contamination, and that reduces the bioreactivity within 24 hours by 40% and up to a maximum of around 60% after 4 weeks in storage. Okay, we've also discussed that preservation mediums do work, but I've got reservations because I don't know whether it increases the amount of corrosion from the surface of the implant, and it's still not as good as removing the hydrocarbons just before we're placing it into the mouth. We've discussed that you get a big increase in bone to implant contact ratio, and that's from treated surface implants and machine surface implants. We've also talked about the bone is more mature, the blood clot's more mature, there's more cells, stronger cells. The body wants to heal 8 times faster around these implants. Everything is upregulated to a very, very significant extent, okay? Now, there was another study. I'll just go through it very briefly because some of you may be placing zirconia implants, but I know that most people don't. It does not change the crystalline structure of the surface of the zirconia implants. So it doesn't damage zirconia by using either an alkali solution or by using UVC sterilization of the surface. Another thing that started to play on my mind as I was going through this, and again, this is something I don't have the data for, but this would be a great research project for somebody who's doing a master's or a PhD or something along those lines, is the prosthetics that we get back from the lab, and I will be going into more podcasts with regards to this. The prosthetics that we get back from the lab are filthy. They're really dirty, okay? But let's say that they're cleaned and we use the correct protocols and we get them as pristine as what we possibly can. Does hydrocarbon contamination happen on the surface of these? I can't see any reason why it wouldn't. What impact does that have on the soft tissue? Now, you heard me earlier turn around and say that once you remove the hydrocarbons off the surface of the implant, it's actually resistant to biofilm adhesion to the surface. So if we got absolutely pristine prosthetics, remove the hydrocarbons from the surface, should we then be looking to see whether we can get predictable muco integration as well as predictable osseous integration? I don't know. You know, these are things that we need to look into in more detail. Now, what I was discussing with regards to the contamination of implant prosthetics, it was I was talking at the ADI members conference a couple of years ago on this topic, and it was Ray McNamara who was on after me talking about this. Absolutely fascinating stuff, to the point where you're going, oh my God, I just need to completely alter the protocols that I'm using before my implant prosthetics go into place, and we will be discussing that at a later date for you. Okay, all right. So you've got different authors, you know, using unbiased techniques, coming to the same conclusion. It's not the same authors time and time again. Most of these are very good studies. A lot of them have been done on animals. So again, another good study would be, is to remove the hydrocarbons and place them in somebody's jaw. And again, split mouth would be great on this. And take ISQ readings of treated versus untreated implants. Over every week over a 12-week period. See what happens in human study. So again, it would be very, very interesting to see that type of stuff. Okay. So I think the last bits of it are just repetitive. Yes, yeah. So again, it's just corroborating the data that we've already been to. They're demonstrating that alkali solutions and UVC chambers are just as good as each other. Here's the results of this paper. Effect on healing on cells. There's a greater maturity of cells by at least 75%, and accelerated healing by at least 85%. That's huge. There's a vast increase in cell maturity and density. All biomarkers indicating improved healing times, and there's an increased blood clot thickness. There's a vast increase in cell maturity and all biological markers of the osseous matrix itself. There's a medium-term improvement in healing and a vast improvement in reverse torque tests. They're all coming out with the same data. They're all saying that. So it does go to. We can argue the point that this is a real phenomenon. Biological aging is absolutely a real phenomenon. It happens on the surface of all implants. And we need to be taking it seriously because it is something that we can easily remove, and it's only going to improve outcomes for our patients. And if we're not improving outcomes for our patients, why are we doing this type of work? So whether you are, as I said towards the beginning, if you're a beginner, you'll come back to this later and you'll find it interesting. You may even find it interesting now, but certainly for colleagues who are placing a fair few implants and they're doing a little bit more complex work. And personally, I think the more complex work that you're doing, the more interesting you're going to find this data, right? Right? So, if you're doing 4 mouths and all of a sudden I'm turning around and saying to you, you know what, you can increase the speed of healing by a factor of 8. You can increase the blood clot thickness. You can increase the bone maturity. You can increase the bone to implant contact ratio. You can get machine surfaces to integrate predictably. That's all fantastic data. That's something that that is why I really enjoyed doing this dissertation. I hope that you've found today's episode interesting. I think I've been a little bit more on track this time than what I was last time around. I think I've stuttered less, but as I said before, I do tend to stutter. I'm sorry about that. It's just I have one idea pop in my head, and before it's out of here, the next one's jumping in already. But I hope I've still managed to get my point across to you. It means a lot that you've decided to chime in and either listen to me drone on, or if you're watching me on YouTube, stare at my face for the best half an hour. It really does mean a lot, and thank you so much. I'm doing this because I'm passionate about the work that I do. I want to share some of my knowledge, and I want to learn from you guys as well. So I'm constantly trying to improve my game, and that's why I'm here. Basically, that's why I'm here. So please, leave a like, please share, please tell other colleagues who may be interested in this type of stuff. If you've got any particular topics that you would like for me to cover, please do let me know. We've already got one planned that I will be recording with Riaz Yar, as I've mentioned on a number of occasions, with regards to occlusion in relation to implants. And I think I will also do some aimed towards people who kind of like considering getting into implants or earlier on in their career, and that will, and I'm going to aim to get Farhan Ahmed on that because he's a great believer in mentoring, and he's a superb surgeon. And so we're going to sit down with him and discuss with him, look, this is how I started, these are the issues that I had, these are the mistakes that I made, these are my thoughts on mentoring, what are your thoughts on mentoring, and hash out kind of like the stages that had occurred for me to get to where I am, and hopefully he will do the same to say that, well, actually, you know what, he found that he went through his career progression in implants, so that you get some sort of indication that when you're getting into this field, it's not you go on one course, you learn everything, that it is a progression. And we are here to we're always here to support colleagues, because we're all doing this to give our patients better lives. So thank you very much for tuning in. I will let you get on with the rest of your day. My dog absolutely wants my attention. I gotta go. Bye.